The total resistance R of a particular group is given by the formula R equals S plus this complex fraction. This formula can be simplified to the form A over B, where A and B contain no fractions. So our goal here is to simplify the right side of this equation so that it's in the form of A over B. Let's do this on the next slide. Let's first focus on the complex fraction. Looking at the fractions in the denominator of the complex fraction, notice how the least common denominator would be t times u, or tu, and therefore the first step is to multiply the numerator and denominator of the complex fraction by tu. This gives us s plus 1 times tu is tu, and then in the denominator we have 1 over t times tu plus 1 over u times tu. And now let's determine these products. If it's helpful, we can write tu as a fraction with the denominator of 1. And now we will simplify before multiplying. Notice here t divided by t simplifies to 1, and here u divided by u simplifies to 1. Notice now in the denominator we have 1 times u plus 1 times t. And therefore the expression simplifies to s plus tu divided by the quantity u plus t. And now we need to add, which means we must have a common denominator. We can write s as a fraction with a denominator of 1. And notice here the least common denominator is going to be u plus t, which means we need to write s over 1 as an equivalent fraction with the denominator of u plus t by multiplying the numerator and denominator by the quantity u plus t. So we have s over 1, and then we multiply the numerator and denominator by u plus t, plus tu over the quantity u plus t. Notice now we do have a common denominator, and therefore when we add the fractions, the denominator is going to remain u plus t, and the numerator is now s times the quantity u plus t plus tu. Let's see if we can simplify the numerator by clearing the parentheses and combining like terms. So now we distribute the s, which gives us su plus st plus tu all over the quantity u plus t. So nothing is going to simplify here. This is the form of the resistance formula that the question is asking us for, where A is the numerator and B is the denominator. So going back to the first slide, we now know R, the resistance, is equal to the quantity Su plus St plus Tu divided by the quantity U plus T. So again, A is equal to the numerator and B is equal to the denominator. And now for the second part of the question, they tell us that S is equal to 31 ohms, T is equal to 68 ohms, and U is equal to 92 ohms, and they want us to find the resistance R, which means we now substitute 31 for S, 68 for T, and 92 for U. Performing this substitution, we have R equals, in the numerator we have 31 times 92 plus 31 times 68 plus 68 times 92. In the denominator we have 92 plus 68. Again, we substitute 31 for S, 68 for T, and 92 for T. Simplifying, in the numerator we have 2,852 plus 2,108 plus 6,256. In the denominator we have 160. The sum in the numerator works out to 11,216, and 11,216 divided by 160 is exactly 70.1. So the resistance is 70.1 ohms. Notice how if the quotient doesn't come out nice, we are asked to round to 2 decimal places. I hope you found this helpful.